Hello everyone, my name is Jerry and today I'll be doing some cool experiments with red cabbage for the upcoming new year. This is my first video and I hope you enjoy it. First, we'll cut the red cabbage into small pieces and then add them into a blender. Then we will add water that is 1:1 ratio to the red cabbage. Then we will take the blended cabbage from the blender and pour it through a filtering paper. After collecting the red cabbage liquid, we can add some salt to make the color change better, easier to see. Stir it well and you'll get this like purplish liquid.
Now, this is because adding salt increases the solute concentration outside the cells, so water moves out of the cell by osmosis. As water leaves, the cell membrane pulls away from the cell wall and becomes damaged, which causes the vacuoles to leak. When that happens, the anthocyanin pigment inside the cells is released into the surrounding liquid.
Next, we will separate the cabbage liquid into 5 bottles. Then we will add some compound and observe the reactions that occur between them and the red cabbage indicator. This is Sprite. When you add some Sprite, you can see that the color changes to a light pink color.
When vinegar, also known as acetic acid, is added to the red cabbage extract, it releases H+ ions into the solution. These ions move into the anthocyanin molecules that stabilizes a different internal arrangement of electrons in anthocyanin, which changes how it absorbs light. As a result, the solution appears towards a light pink color.
This is vinegar. After adding some vinegar, the color changes to a red color.
Pepsi or phosphoric acid works similar to vinegar but through stronger acids. Phosphoric acid releases H+ ions into the solution, increasing acidity. These H+ ions protonate anthocyanin molecules in the extract. Because phosphoric acid can release H+ ions more stably than acetic acid, the color change can be more intense, shifting the color towards red.
This is alkali, which is also sodium carbonate. After adding some sodium carbonate, we can observe that the color changes to a dark greenish.
Baking soda, also known as sodium bicarbonate. When it dissolves in water, it forms bicarbonate ions that react with water to produce some OH- ions. These OH- ions remove H+ from anthocyanin molecules. When anthocyanin loses H+, its internal bonding and electron distribution change. This shifts the wavelength of light it absorbs, causing the color to move towards blue.
Color. The last compound we're going to add is baking soda. After adding baking soda, we can observe that the color changes to a bluish liquid.
Last is alkali, or sodium carbonate. Sodium carbonate dissolves to form carbonate ions, which are stronger bases than bicarbonate ions. These carbonate ions remove more H plus from anthocyanin and from the surrounding solution. This stronger deprotonation causes a larger structural change in anthocyanin, which alters the color to dark green.
And that's it for today's experiments. Stay tuned for more experiments in the future. Thank you for watching.